Chapter 4.3, Trigonometric Ratios. The primary trigonometric ratios are sine, cosine, and tangent. A trig ratio is a number that describes the ratio of two sides of a triangle compared to each other and relative to angle theta. SOHCAHTOA helps us remember the primary trig ratios, which are sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. If we think of a right triangle inscribed within a circle, like we have here, the side opposite from our theta is the y, and the side adjacent to our angle theta is the x. And then we have our hypotenuse, which in a unit circle is 1. So for a right triangle drawn in a circle like the diagram, we can write our opposite is y and our hypotenuse is the radius of the circle. For the unit circle, the radius is 1, so we can write y over 1, which equals y. This part is for the unit circle. Cosine, same thing. The adjacent side in our triangle is the x value. The hypotenuse is the radius of the circle. In a unit circle, the radius is 1, so we have x over 1, which leaves us with just x. And then for tan theta equals opposite over adjacent, our opposite side is y and our adjacent side is x. If p theta equals xy is the point on a terminal arm of angle theta that intersects the unit circle, then sine of theta equals y over 1, or just the y coordinate of the point, and it follows that cos theta equals x over 1, or the x coordinate of the point, and tan theta equals sine over cos, which equals, that should totally say y over x, not x over y, so hopefully in your notes it says y over x. If not, cross it out, write y over x. Using these trig ratios, we can write an ordered pair xy, which is any point on the unit circle, as cos theta sine theta. So x is the same as cos theta, and y is the same as sine theta. If we take the reciprocal of each of the above ratios, we produce the reciprocal or secondary trigonometric ratios, cosecant, secant, and cotangent. Cosecant theta is equal to 1 over sine theta, which is equal to 1 over y, since sine theta, that should really say theta there, since sine theta equals y, then 1 over sine theta would equal 1 over y. Secant theta equals 1 over cos theta equal to x, so secant theta is 1 over x, and then cotan theta equals cos theta over sine theta, which equals x over y. This one is cosecant, this one is secant, and this one is cotangent. And it does seem like the names of cosecant and secant should be opposite. That's kind of how I remember which one is which. When I think about it, to me, secant seems like it should be the reciprocal of sine, and cosecant seems like it should be the reciprocal of cos, but I know that it's backwards, so when I think cosecant, I go, okay, that's backwards of what I think it should be, so then it's 1 over sine, and secant is 1 over cos. Maybe that'll help you, maybe it won't. It's just how I remember them. The point B, negative 1 over 3, 2 root 2 over 3, lies at the intersection of the unit circle and the terminal arm of an angle theta in standard position. We know it's on the unit circle, so radius equals 1. Draw a diagram to model the situation. Determine the values of the 6 trig ratios for theta and express in lowest terms. So for the diagram, I'm going to super zoom in here. The x value of our point is negative 1 over 3. I can plot that point. Here at the negative x-axis on the unit circle, we have a negative 1. So if I split this section from 0 to negative 1 into 3 sections, each of those would be negative 1 over 3. So if I put a line here and here, that's about 3 equal sections. Then the first one is negative 1 over 3. If I go straight up from there until I intersect the unit circle, so there's where my point B would lie on the unit circle. My reference angle, theta r, would be in here. Then my side opposite the reference angle is the y-coordinate, and then the side adjacent to the reference angle is the x-coordinate of the point. Next, we need to determine the values of the 6 trig ratios for theta and express in lowest terms, starting with sine theta, which equals opposite over hypotenuse. It's on the unit circle, so our hypotenuse is 1, it's the radius of the circle. And then our opposite side is the y value, which then just equals y, which in this case, the y value is 2 root 2 over 3. Then I can do the reciprocal function or the secondary function for sine theta, which is cosecant theta is 1 over sine theta. So the reciprocal of what we got for sine theta, which would be 3 over 2 root 2. And then I can rationalize the denominator by multiplying by root 2 on top and bottom. And I get 3 root 2 over 2 times 2, which is 4. Next is cos theta, which equals adjacent over hypotenuse. In the unit circle, the hypotenuse is the radius, which equals 1. The adjacent is the x-coordinate, so we really just get x, which is negative 1 over 3 in this case. And then the secondary trig function would be secant theta, which is 1 over cos theta, which is negative 3 over 1, which equals negative 3. Then we have tan theta, which equals opposite over adjacent. The opposite in the unit circle is the y-coordinate, and the adjacent is the x-coordinate. So we get the y-coordinate of 2 root 2 over 3 divided by the x-coordinate of negative 1 over 3. When we divide by fractions, we multiply by the reciprocal, so we get 2 root 2 over 3 times 3 over negative 1. These divide out, we get 2 root 2 over negative 1, which is just negative 2 root 2. And then the last trig function, the secondary trig function, cotan theta, which is 1 over tan theta, which would be 1 over negative 2 root 2 in this case. And we can rationalize our denominator by multiplying by root 2, top and bottom. And we would get root 2 over negative 2 times 2, which gives us negative root 2 over 4. Calculating exact values. To find the exact value of a trigonometric ratio, given the angle theta, combine your knowledge of the cast rule, reference angles, and the first quadrant of the unit circle. You may also refer to the special triangles instead of the unit circle, as the same information can be obtained. So here we have a diagram of the first quadrant of the unit circle and each of our special angle measures and the xy values for those points. We now have that a point xy is equal to cos theta sine theta for points on the unit circle. And then tan theta equals y over x. So looking at this diagram, I'm going to zoom in a bunch. At an angle measure of 0, the 1 is cos theta, so cos of 0 is 1, and sine of 0 is 0. Then tan theta for theta equals 0 would equal sine theta, which is 0, over cos theta, which is 1. So tan theta for theta equals to 0 would equal 0. In the next angle, 30 degrees or pi over 6, we have x equals root 3 over 2, which means cos of 30 degrees or cos of pi over 6 equals root 3 over 2. And then we have y equals 1/2, which means sine of 30 degrees or sine of pi over 6 equals 1/2. Then tan of 30 degrees or tan of pi over 6 would equal the y value of 1/2 divided by the x value of root 3 over 2. When we divide by a fraction, we multiply by the reciprocal, so 1/2 times 2 over root 3, which gives us 1 over root 3. And we can rationalize the denominator by multiplying by root 3 on top and bottom, and then we would get root 3 over 3. So either 1 over root 3 or root 3 over 3 is the value of tan 30 or tan of pi over 6. At theta equals 45 degrees or pi over 4 radians, cos of theta is root 2 over 2 and sine theta is also root 2 over 2. Then tan theta would be root 2 over 2 divided by root 2 over 2. So we're taking a number, dividing it by itself. That would give us 1. For theta equals 60 degrees or pi over 3 radians, cos theta equals 1/2 and sine theta equals root 3 over 2, which means tan theta equals root 3 over 2, the y value, divided by 1/2, the x value, which equals root 3 over 2 times 2 over 1, which gives us root 3 over 1, or just root 3. And then for theta equals 90 degrees or pi over 2 radians, cos theta equals 0 and sine theta equals 1. Then we'd have tan theta would equal the y value, which is 1, divided by the x value, which is 0, but we can't divide by 0, so tan theta is undefined. And again, you can use your special triangles. We have the 30, 60, 90 special triangle. To adapt it for the unit circle, we need to divide everything by 2 so that we get the hypotenuse equal to 1, divided by 2, divided by 2. And then if you're looking from angle 30, you would have 1/2 is your opposite, and root 3 over 2 is your adjacent. And if you were looking from angle 60, it would be opposite. So root 3 over 2 would be opposite from root 60, which would make it your y value, and 1/2 would be adjacent from 60, which would make it your x value. Then our other special triangle, the 45, 45, 90 triangle, we need to divide all sides by root 2 to get 1 as our radius or hypotenuse. Divide by root 2, divide by root 2. Then both of our acute angles are the same, so we have the opposite side, which is the y value is 1 over root 2, and the adjacent side, which is the x value, is 1 over root 2 from either of the acute angles. So let's do an example. To find the exact value of cos of 135 degrees, draw a diagram. 135 degrees is in quadrant blank. So 135 degrees is more than 90, but less than 180. So it'd have to be in quadrant 2. Cas indicates that cosine, so in quadrant 2, cast, C-A-S-T. So in quadrant 2, sine is positive, which means all the others are negative, so cosine is negative. The reference angle theta r equals, if we take, it's in quadrant 2, so if we start with 180 degrees and subtract our angle of 135, what do we get? We're left with 45 degrees. So theta r is 45 degrees, which means our terminal arm is about there, halfway between the x and y axes. That's 45 degrees. And theta is 135 degrees. By the unit circle or special triangles, cos theta r equals. So looking at the unit circle, 45 degree reference angle gives us root 2 over 2 for both the x and the y. Cos is the x value, so it would be root 2 over 2. So by the unit circle or special triangles, cos of theta r, so cos of 45 degrees is root 2 over 2. And then therefore cos of 135 degrees, it's root 2 over 2, but it's in quadrant 2, which means it's negative, so negative root 2 over 2. Draw diagrams to help you determine the exact value of each trigonometric ratio. I'm going to super zoom in on this. First one is tan of pi over 2. It's going to help to either have your first quadrant of your unit circle drawn with all of our special angles and the coordinate points, or you can use the special triangles. So I'm going to use the special triangles. The 30, 60, 90 special triangle. It's a right triangle, 90 degrees, 60 degrees, 30 degrees. It starts out with a hypotenuse of 2, adjacent side to 60 is 1, and opposite side to 60 is root 3. We then adapt it for the unit circle by dividing all measures by 2 so that the hypotenuse becomes 1 to equal the radius of the unit circle. So 1, 1/2, and root 3 over 2. Then if I'm focused on angle 60 in this particular triangle, the opposite side, which is the y value, is root 3 over 2, and the adjacent side, which is the x value, is 1/2. I can also rotate the triangle so that angle 30 is in the bottom left. (30 degrees, 60 degrees, 90 degrees. Our sides are all the same. So hypotenuse is 1. The side opposite from 60 is root 3 over 2, and the side adjacent to 60 is 1/2. Then if we're focused on angle 30, the opposite side is the y value, which is 1/2, and the adjacent side, is the x value, which is root 3 over 2. Then we have our other special triangle, which is the 45, 45, 90 triangle. We have 45 degrees, 45 degrees, and 90 degrees. Our sides start as 1, 1, and square root 2. We then adapt it for the unit circle by dividing all sides by square root 2 so that the hypotenuse equals 1, which is the radius of the unit circle. For reference angles of 45 degrees, we have an opposite side, which is the y value of 1 over root 2, and an adjacent side, which is the x value, also equal to 1 over root 2. If we rationalize the denominator, then we get root 2 over 2. Since that's all in degrees, let's also write what those are in radians. So for 60 degrees, that's pi over 3 radians. 30 degrees is pi over 6 radians. And 45 degrees is pi over 4 radians. Okay, so tan pi over 2, we want the exact value of tan pi over 2. Draw a diagram to help us. Zero is here, pi is here, so pi over 2 would be halfway in between, which is at the positive y-axis. The xy value there would be 0, 1. Then tan theta equals opposite over adjacent, which is the opposite side for an angle in the unit circle is the y value, and the adjacent side is the x value. So then we get tan of pi over 2 equals the y value is 1, the x value is 0. But we can't divide by 0, so this tells us that tan of pi over 2 is undefined. Next is cosecant of 7 pi over 6. Draw a diagram. 7 pi over 6, can we reduce that fraction? No, we can't. So that means that pi over 6 is our reference angle. Which quadrant would it be in? Well, the positive x would be 0, the negative x would be pi. If we wrote pi in terms of being over 6, it would be 6 pi over 6. So 7 pi over 6 would have to be after that. So it's going to be in quadrant 3. And it has a reference angle of pi over 6, which is our smallest reference angle. It's going to look something like this. Then the coordinates, if I look at 7 pi over 6, reference angle of pi over 6, which is here, our x value is the adjacent, which is root 3 over 2. Our y value is the opposite, which is 1/2. So root 3 over 2 and 1/2. And then it's in quadrant 3, where x and y are both negative. So negative root 3 over 2 and negative 1/2. Then cosecant theta equals 1 over sine theta. In the unit circle, sine is y, so that's 1 over the y value. Or if the y value is a fraction, it's the reciprocal of the y value. Then cosecant of 7 pi over 6 equals the reciprocal of negative 1/2, which would be negative 2 over 1, which equals negative 2. So cosecant of 7 pi over 6 equals negative 2. Next, sine of negative 300 degrees. Draw a diagram. negative 300 degrees, so we're going clockwise. The whole way around is 360, so our terminal arm is stopping 60 degrees before making a full rotation, which would put it there. So that's negative 300. And then our reference angle would be 60 degrees. So looking at our special triangles, when theta equals 60, our point, the x value is 1/2, and the y value is root 3 over 2. So 1/2 and root 3 over 2 is our point, and then we just have to decide the signs. It's in quadrant 1, so they're both positive. So 1/2 root 3 over 2. Sine theta equals opposite over hypotenuse. But remember, in the unit circle, hypotenuse is 1, so opposite over 1 is really just the opposite. And the opposite side is the y coordinate, so sine theta really just equals y when we're in the unit circle. Then sine of negative 300 degrees equals the y value of the coordinate where the terminal arm for that angle meets the unit circle, which is root 3 over 2. We do have a little system that we can use to find these exact values in our calculator, so let's try that with this question. First, we need to enter the trig function into our calculator, but we need to make sure we're in the correct mode. So in the TI, I would go to mode. In the Casio, I would go shift menu. Then I go down until I'm on the radians degrees. This question's in degrees, so I need to change to degrees, hit enter, then exit. For the Casios, you go down until you're on angle, and then you hit F1 for degrees. So we enter sine negative 300 and then calculate that. We get 0.866 blah blah blah. So it says take note if your answer is positive or negative. So okay, we have a positive answer. Step 2, we're going to square that answer. So it's important to square the whole thing. So you need to just hit the x squared button and it'll take your last answer and square it. Then hit enter and we get 0.75. Step 3 says change this into a fraction. So Casio users just hit the F to D button, fraction to decimal, and TI's math, enter, enter, changes to 3 over 4. And then it says to mentally square root your number and add the sign from step 1. So if we square rooted 3 over 4, we would get the square root of 3 over, square root of 4 is 2. So root 3 over 2. And from when we did sine of negative 300, we got a positive answer. So it would be positive root 3 over 2, which is what we got over here, positive root 3 over 2. So if you want to use that trick, if you can remember all those steps, go for it. It's a good way to check your answer to see if you got the correct answer. Secant of 60 degrees. Draw a diagram. $60 degrees is about here. The x and y values at 60 degrees, let's refer to our special triangle. The x value is 1/2 and the y value is root 3 over 2. It's in quadrant 1, so they're both positive. 1/2 and root 3 over 2. Then secant theta equals 1 over cos theta, which equals 1 over x for the unit circle. Then secant of 60 degrees equals the reciprocal of the x value, where the terminal arm meets the unit circle. The x value is 1/2, so we would get 2 over 1, which equals 2. Then secant of 60 degrees is equal to 2. Cos of 150 degrees. Start with our diagram. (150 degrees) is 30 degrees less than 180, so about here. Our reference angle is 30 degrees. And then we want to know our coordinate point where the terminal arm meets the unit circle. So look at our special triangle 30, 60, 90 from 30 degrees. We have from 30 degrees, our x value is √3/2 and our y value is 1/2. We are in quadrant 2, so the x value is going to be negative. So negative √3/2 and y value is positive 1/2. Then cos theta equals adjacent over hypotenuse. Adjacent is the x value, hypotenuse is 1 for the unit circle, so that just is x. Then cos of 150 degrees is the x value for the point where the terminal arm of angle 150 degrees meets the unit circle. The x value there is negative √3/2. Cosecant of 240 degrees. Start with our diagram. 240 degrees is more than 180, which is here, but less than 270, which is here. It's 60 degrees more than 180, so it'll be about here. Reference angle would be 60 degrees. And then our angle is 240 degrees. It's in quadrant 3, so x and y are both negative. We want to look at our special triangle with 60 degrees. So special triangle, 60 degrees. The x value is 1/2. The y value is √3/2. They're both going to be negative in this case. Negative 1/2 and negative √3/2. Then cosecant theta equals 1 over sine theta, which equals 1 over y for the unit circle. And cosecant of 240 degrees equals the reciprocal of the y value at 240 degrees. The y value is negative √3/2, so the reciprocal would be negative 2 over square root 3. Then we can rationalize the denominator by multiplying top and bottom by square root 3, and we would get cosecant of 240 degrees equals negative 2 √3/3. Secant 225 degrees. Start with our diagram. This is 180 degrees. This is 270 degrees. 225 degrees is halfway between those 2 points. So a reference angle of 45 degrees and an angle of 225 degrees. The point, let's look at our 45, 45, 90 triangle. We have x value of 1 over √2 and y value is the same, 1 over √2 or √2/2, whichever one you want to use. Then we're in quadrant 3. Both of them are negative, so negative 1 over √2 and negative 1 over √2. Then secant theta equals 1 over cos theta, which for the unit circle is 1 over the x value. Then secant of 225 degrees is equal to the reciprocal of the x value at angle 225 degrees. The x value is negative 1 over root 2, so negative root 2 over 1, which equals negative root 2. Secant of 225 degrees equals negative square root 2. Last one, cotan of 5 pi over 3. Start with our diagram. Five pi over 3, we have 0. We have pi, which would be 3 pi over 3. And then when we get back to the positive x-axis, that would be 2 pi, which is equal to 6 pi over 3. So that means that 5 pi over 3 is 1 pi over 3 less than a full rotation. So here, our reference angle is pi over 3, and our angle is 5 pi over 3. Let's check out our special triangles. Looking for the reference angle pi over 3, which is here for 60 degrees. So x is 1/2 and y is root 3 over 2. 1/2 and root 3 over 2. We need to assign the signs for both of them. X would be positive in quadrant 4, so positive 1/2, and y would be negative root 3 over 2. Then cotan theta equals 1 over tan theta, which equals tan is opposite over adjacent, so 1 over tan is adjacent over opposite, which for the coordinate points is the opposite side is the x over the y. Then cotan of 5 pi over 3 would equal x value is 1/2 divided by the y value of negative root 3 over 2. To divide fractions, we multiply by the reciprocal, so 1/2 times negative 2 over root 3. These 2's divide to 1, so we're left with negative 1 over root 3, and we can rationalize the denominator. We get negative root 3 over 3. So cotan of 5 pi over 3 equals negative root 3 over 3. Approximate values of trig ratios. We're using our calculator for approximate values. You need to make sure the mode is correct, so you're going to have to switch back and forth between degrees and radians. And then when dealing with cosecant, secant, and cotangent, use the reciprocal of sine, cosine, and tangent. Example sine of 0.5. Bring up our calculator. It doesn't have a degree symbol, so we know it's in radians, so we need to make sure that our calculator is in radians. And I check, it's in degrees right now, so I go down, over to radians, enter, exit, and now I can do sine of 0.5 equals 0.479 ... And then sine of 30 degrees. Now we need our mode to be in degree. Go to mode, down to radians, degrees, change to degrees, hit enter, exit, and then sine 30 gives us 0.5. Example, find the approximate value of each trigonometric ratio, round the answer to 4 decimals, justify the sign of each answer. Sine of 1.92, there's no degree symbol, so this is in radians. I need to go mode, down, change that to radians, exit, then I go sine 1.92 equals 0.9396. And then justify the sign of each answer. Well, which quadrant is this in? We know that this is 0, pi over 2, pi, and 3 pi over 2. Pi radians, pi is 3.14, and our number is 1.92, so it's not that big. Pi over 2, secant pi divided by 2 is 1.57, so it's bigger than that, so it's in quadrant 2. Then using the cast rule, CAST, we get that sine is positive because the terminal arm of our angle is in quadrant 2. Next one, tan of negative 500 degrees. Check your mode. I'm in the wrong mode. I need to change it to degrees. I do that. Then I do tan negative 500, enter, and I get, rounded to 4 decimals, is 0.8391. And then justify the sign. Negative 500, so 360, negative 360 would be once around that way. Another 360 would be too much. 360 times 2 is too much. It's 720. So if we take 500 and minus 360, we would get 140. So we need to go another 140 around clockwise. Going clockwise, negative y-axis would be negative 90 degrees. Negative x-axis would be negative 180 degrees. So negative 140 degrees would be somewhere in that quadrant 3, somewhere in here. And then using cast rule, CAST, here we have that tan is positive. So we justified our positive answer of 0.8391. Secant of 85.4 degrees, that equals 1 over cos of 85.4 degrees. Let's make sure we're in degree mode. Yes, we're in degree mode. Hit exit. I can enter a fraction, math, enter 1 over cos 85.4, enter, and we get 12.46899, which would round to 12.4690. And then justify the sign, which is positive. This is 0 degrees, this is 90 degrees, so 85.4 would be about here. The cast rule, CAST, we're in quadrant 1, where all trig functions are positive. Last one, cotan of 3. Cotan is 1 over tan 3. Are we in degrees or radians? There's no degree sign, so this is radians. Go to mode. We need to change that to radians. Hit enter, exit. Then we want a fraction, math, enter. We have 1 over tan 3. And that gives us cotan 3 equals negative 7.0153. Justify our sign, which is negative in this case. This is 0 radians, this is pi radians. Pi is 3.14, so 3 would be a little bit before that, which is in quadrant 2. Cast rule, CAST. This tells us that sine is positive and everything else is negative, which means cotan would be negative. Determine the measure of all angles that satisfy the following conditions. Use a diagram to show the possible answers. First one, cos theta equals positive 0.843 in the domain negative 360 degrees is less than theta is less than 180 degrees. Give the answers to the nearest tenth. The first step is to figure out the reference angle by doing theta r equals cos inverse of 0.843. The domain tells us that we need to be in degree mode. Our calculator. Check the mode. I'm in radians right now. I need to change that to degrees. And then I can go second cos 0.843. And I get 32.5 to the nearest tenth, so 32.5 degrees is our reference angle. Next, I can draw my unit circle. And using the cast rule, because cos theta is positive 0.843, then our angles will have to be in either quadrant 1 or quadrant 4, because that's where cos is positive. So 32.5 degrees in quadrant 1 is about here. And then in quadrant 4, a reference angle of 32.5 degrees is about here. Our reference angle is theta r equals 32.5 degrees, and that's there. And then also here we have a reference angle of 32.5 degrees. The domain for theta is greater than negative 360 degrees and less than 180 degrees. We can have theta equal to 32.5 degrees. We could also have theta equal to negative 32.5 degrees. So if we go the negative direction to here, that's negative 32.5 degrees. Then can we get any more positive angles? Our domain ends at positive 180, so it ends over here. So to get any more positive angles, I would have to go around a full rotation and then come back, which would be more than 180. So I'm not going to be able to get any more. We can test this out by doing 32.5 degrees plus 360 degrees, and that's going to give us 392.5 degrees, which is too big for our domain, so we can cross that out. Then going the negative direction, we have our negative 32.5 degrees. We can also go around and get to this because our domain is negative 360. So we're allowed to go a full rotation, which means that this angle here would be part of that domain. To get to that one, we would start with negative 360 degrees, and then we would add 32.5 degrees because we want 32.5 degrees less than a full rotation, but in the negative direction. So then we get negative 360 plus 32.5 is negative 327.5. degrees, which fits in our domain for theta. So theta equals negative 327.5 degrees. So we end up with three different angles that would give us cos theta equals 0.843 in the domain of theta greater than negative 360 and less than 180. B, sine theta equals 0 in the domain theta is greater than or equal to 0, less than or equal to 0. Give exact answers. So exact answers for this one, that means it's going to be one of our special angles. Sine theta equals to 0. We know that sine is the y value in the unit circle. Let's draw the unit circle. Where is y equal to 0? Y is equal to 0 here and also here. So we have the point 1, 0 and negative 1, 0. This is at an angle of 0 degrees. This is at an angle of 180 degrees. We're only going between 0 and 180, or it could be equal to those two. So in this case, our solutions are theta equals 0 degrees and theta equals 180 degrees. Cotan theta equals negative 2.777 in the domain negative pi is less than or equal to theta, it's less than or equal to pi. Give the answers to the nearest tenth. So we're in radian mode. I'm in degrees at the moment. I need to change that to radians. Exit. This is cotan theta equals negative 2.777, which means that tan theta equals 1 over negative 2.777. Then to get the reference angle, theta r, we would do tan inverse of negative 1 over 2.777. And theta r equals second tan math fraction, enter, negative 1 over 2.777, and we get negative 0.3456, so to the nearest tenth would be negative 0.3 radians. I can draw my unit circle. Cotan is negative using the cast rule, C-A-S-T. Where is tan negative? Because that would be the same place that cotan is negative. Tan is negative in quadrant 4 and in quadrant 2. So that's where our angles are going to be. We have a reference angle of 0.3 in there. It's negative 0.3, but we can just think of it as 0.3. How much is that in terms of a quadrant? One quadrant is pi over 2. Let's see what that equals. Pi divided 2 is 1.5. So 0.3 is quite a small portion of that. So let's say that 0.3 is maybe about here and here. Somewhere in there, we know it's in those two quadrants, and we know that the reference angle is 0.3 or negative 0.3. Then our domain for theta is that theta is greater than or equal to negative pi and less than or equal to pi. That means we can go half a rotation in the negative direction, and that's it. So there's only one possible angle there, which is this one, and we can go half a rotation in the positive direction, and there's only one possible angle, which is there. This is 0. This would be pi if we're going the positive direction, and negative pi if we're going the negative direction. If we can go to negative pi, so from 0 to negative pi, there's only one angle in there that's a solution, which is this one. And then if we can go from 0 to pi, there's again only one angle in there, which would be this one. Then our solutions. The negative angle would be theta equals negative 0.3. And then our positive angle would be this. Theta equals, start with pi, which is quadrants 1 and 2, and subtract the reference angle, which is 0.3. Pi minus 0.3 is 2.8 rounded to the 10th, so our second solution is theta equals 2.8 radians. Next one, cosecant theta equals negative 2 over root 2. In the domain, negative 2 pi is less than or equal to theta. It's less than or equal to 2 pi. Give exact answers. Then we don't want to use our calculator for doing the inverse trig function like we did with this one and other ones. We need to think of our special triangles instead. Cosecant theta equals 2 over root 2. Cosecant theta is 1 over sine theta. So that tells us that sine theta equals the reciprocal of negative 2 over root 2, which is negative root 2 over 2. Which special triangle is this from? It's the 45, 45, 90 triangle, or the pi over 4, pi over 4, pi over 2 triangle. Then that tells us that our reference angle, theta r, equals pi over 4. I'm going to draw a bigger diagram this time because I happen to know that I'm going to have more answers. Using the cast rule, we have sine theta is negative. Which quadrants is sine negative? In quadrant 3 and quadrant 4. And then we have a reference angle of pi over 4, which is halfway between the x and y axes in each of those quadrants. Then our domain is from negative 2 pi to 2 pi. This means a full rotation in the negative direction and a full rotation in the positive direction. So if I start at 0 and I go a full rotation in the negative direction, how many angles do I have there? I have 1, 2 angles. And if I go from 0 and go in the positive direction, a full rotation, how many solutions do I have here? I have 1 angle, 2 angles. So I'm going to have 4 solutions. We have one that will be here going this way, one that will be this, so theta 1, theta 2, and then if we go the positive direction, we have this one here is theta 3, and then all the way around to here is theta 4. First solution, theta 1, is the negative direction, and it's just our reference angle, so negative pi over 4. The second solution, theta 2, would be negative pi plus the reference angle of pi over 4, which gives us negative pi would be negative 4 pi over 4, and then plus pi over 4, which equals negative 3 pi over 4. So theta 2 is negative 3 pi over 4. Then theta 3, going in the positive direction now, we're past quadrants 1 and 2, so it'd be pi plus the reference angle of pi over 4, which is 4 pi over 4 plus pi over 4, which gives us 5 pi over 4. So theta 3 is 5 pi over 4. And last solution, theta 4 is pi over 4 less than a full rotation. So full rotation is 2 pi minus pi over 4. 2 pi can be written as 8 pi over 4 minus pi over 4, which equals 7 pi over 4. So theta 4 equals 7 pi over 4. Last example, the point D, negative 5, negative 12, lies on the terminal arm of angle theta in standard position. What is the exact value of each trig ratio for theta? So this point is not on the unit circle. It does not say anywhere that's on the unit circle. Let's draw our axes. I have negative 5, let's say that's here, negative 5 for the x value, and then negative 12, let's say that that's here for the y value. I go down and across, and where those 2 points meet, that's where my point is. I can join that to the origin. There's my terminal arm, and that's the point negative 5, negative 12. I need to know the hypotenuse, because it's not a unit circle, so it's not 1. So we need to calculate it. A squared plus b squared equals c squared. Negative 5 squared plus negative 12 squared equals h squared. 25 plus 144 equals h squared. That gives us 169 equals h squared, and then we square root both sides, and h equals 13. We'll start with the sine ratio. Sine theta equals opposite over hypotenuse, which equals the y value over the hypotenuse. So sine theta equals negative 12 over 13. Then the reciprocal function, cosecant theta equals 1 over sine theta. Then cosecant theta would equal negative 13 over 12. Cos theta equals adjacent over hypotenuse, which is the x value over the hypotenuse. In this case, that means that cos theta is negative 5 over 13. Then the reciprocal trig function, secant theta, is 1 over cos theta. In this case, secant theta would equal negative 13 over 5. And tan theta is opposite over adjacent, which is the y value over the x value. So tan theta in this case is negative 12 over negative 5, which becomes 12 over 5. And then lastly, cotan theta is 1 over tan theta, then cotan theta here would equal 5/12. That brings us to the end of Chapter 4, Lesson 3.